All right, so this is going to be a 2-day lesson to find the real zeros of polynomials. So you'll notice that I've done a little edit to the homework in the top. Please pay attention to the homework that's posted in each Google Classroom assignment and in the calendar that's both in the stream and in the classwork tab. So let's get started. Get yourself ready for notes. Now we're going to talk about, first thing is we want to talk about rational zeros, like what does that mean? So a rational number, right, that's one that can be written as a fraction, and then it's a root or a zero, which means that it's wherever that polynomial is equal to 0. So a number I can plug into the function that equals 0. So if we're given a polynomial, the question is, what can I plug in for x that's going to make this whole thing equal 0? Now, for rational numbers, the nice thing is that there's only so many options. If the polynomial is equal to ax to the n plus bx to whatever power, and so on, plus k for the constant term, all rational roots are going to be a factor of the last number. So this would be in terms of, this is like the lowest degree over a factor of the highest. So they just need to be in order. So you take your two terms and you're like, these are my only options. So for number 1, I have my a here, and then k is the last one because they're all nicely in order. If they're not in order, you can just put them in order. You can tell by looking what the degree is. So the only possible numerators of any rational root would be 1, 8, 2, or 4. And you notice there's positives and negatives, so plus or minus. And the only possible denominators are 1 or 2. Again, plus or minus. In number 1, it just asks you to list all of them. So all you need to do is say, okay, well, of these fractions, my numerator can be 1, 2, 4, or 8. My denominator can be 1 or 2. And then we're plus or minus out in front. So what I would say is I'm just going to go down the list like this, over 1, because that's easy. So then I have, for the first part, I've got plus or minus 1 over 1, plus or minus 2 over 1, plus or minus 4 over 1, plus or minus 8 over 1. Now I'm going to have denominators of 2, plus or minus 1 over 2, plus or minus 2 over 2. Which, I can simplify that. I don't need that to write that one because I already have plus or minus 1, right? That's right there. So don't need to worry about that. What about 4 over 2? Well, that's plus or minus 2. And 8 over 2 is plus or minus 4. So this list that we have here are the possible rational roots for this polynomial f of x. Now, that's a lot of numbers to test. So when it asks here in number 2, find all the rational zeros of p of x, it's a much smaller amount because I know that here my a is equal to 1. So all my denominators are going to be 1. And here k is negative 2. So we're just looking at 1, 2, positive or negative. So my possible answers are plus or minus 1 over 1 or plus or minus 2 over 1. Factors of k over factors of a. So since there's only 4 options, I'm just going to list them out and ask myself, do they equal 0? P of 1, P of negative 1, P of 2, P of negative 2, and I'm just going to plug that into the polynomial given and see if it equals 0. So the first one would be 1 cubed minus 5 times 1 minus 2, which is 1 minus 5 minus 2. Oh, that's not 0. Negative 1 would be negative 1 plus 5 minus 2 with a little evaluating. That's not 0. Positive 2 is 8 minus 10 minus 2. Well, that's not equal to 0. And the last one would be negative 8 plus 10 minus 2. Oh, that's 0. So what that means is that the only rational 0 is negative 2. Now, so that's going to be your first assignment, is just finding the rational zeros. However, we would guess, based on this polynomial here, x cubed minus 5x minus 2, is that there would be more zeros. And this is because of the fundamental theorem of algebra. So the fundamental theorem of algebra says that the degree is equal to the number of factors. Now, factors can be rational numbers, real numbers, or complex numbers. And some of those factors might be repeated, like they might have multiplicity. But if I'm looking here, I only have 1 0 right now, and I expect there to be 3. So we're going to use our division skills from earlier in the week to help us find the other 2. So the way that we're going to think about this is, right, we expect 3. Right now, we only know that p of negative 2 is a 0. So what that means is that there is a 0 at x equals negative 2. If I add 2 to both sides, that means that this is a factor of the polynomial. So if I know that x plus 2 is a factor, what I want to do is I want to divide out that factor and see what's left. So I'm going to use my division skills and say, well, what happens when I divide that out? X cubed, and then again, it's missing that x squared term, so we'll put that in. Minus 5x minus 2. And we're going to do our long division. What times x is x cubed? That's squared. And then multiply that down, plus 2x squared, and subtract, which leaves me with negative 2x squared. Bring down the negative 5x. X times what is negative 2x squared? It's negative 2x. So that becomes negative 2x squared minus 4x when I multiply that by 2. And when I subtract all of those, they become positive. So this is negative x minus 2. Bring down the constant, which is just negative 1 times the denominator. And this is how you know that this makes sense, is because remember, we know that this is a factor from here. And so if your remainder is not equal to 0, you've done something wrong. So if you end up with a remainder, you're like, okay, I probably dropped a negative, I multiplied by something weird. That is what's going to happen. So now we have one of our factors, and we have a remaining quadratic. So we've got one root there. And now to find the others, we're looking at x squared minus 2x minus 1. In order to find the roots of that, where's that equal to 0? Oh, you can just use the quadratic formula. And we know they're not going to be rational because we couldn't factor it any farther. There was only that one. So I'm going to use the quadratic formula, where a is equal to 1, b is equal to negative 2, c is equal to negative 1. So x is equal to negative 2, so positive 2, plus or minus the square root of negative 2 squared minus 4ac all over 2a. So we'll do some simplifying. That's 2 plus or minus the square root of 4 plus 4 all over 2, which is equal to 2 plus or minus the square root of 8 over 2. Simplify the square root of 8 into 2 root 2 over 2. And I'm going to simplify by dividing a 2 out of everything. And we have our final answer as 1 plus or minus root 2. So if I'm finding all the zeros of this problem here, the zeros would be negative 2 from before, 1 plus root 2, and 1 minus root 2. So you've got 2 days to work on this big section, finding both rational and real zeros. Talk to you later, and if you've got questions, set up a Zoom call, nominate things in the form, or leave something